Okay, so based on that, well, let's hope the pen works. Based on that little investigation here, it wants us to discuss, you know, every single quadratic we look at, we always compare it to the parent function. Yes? Y equals x squared. That is the most basic. We call it the, I'm going to write it again here. This is the parent function or parent quadratic. You'll hear that a lot in grade 11. So what did we say that h value does? So when we're comparing the x squared to the x minus h squared, so we can say that this new parabola is a parabola that is, we'll say, shifted horizontally left or right. That's what this thing does. Right there. Now remember, the ones in the brackets are a little weird because the original equation of this thing says x minus h squared. So when you substitute in a positive value for h, it'll look a lot like this. So when it looks like it's x minus 6 or x minus 3 or x minus 1, really, we know the parabola is moving to the right. Although it looks like it's x minus 2, we think negative 2, but we've really got to just focus in here and say, well, it's in the brackets. The brackets is a little bit of funny territory, so it's kind of the opposite of what happens in the brackets. But truly, we're subbing in a positive here, so it might look like it's negative. So we'll say moves, what can we say, to the right, h units. And then if we substitute in a negative value, right? If we subbed in a negative 2 into this thing right here, it would look like this, like y equals x minus negative 2 squared, right? In which I said before, the math people say, no. This really should be expressed as x plus 2 squared. So it's going to look like plus something. And we should know that that means go to the left. We'll say moves left h units. That's all we kind of need to know. H value moves left and right, but just be a little careful with it. Now, when compared to the graph y equals x squared, how about that k value? This one at the end here, this k value, is a parabola that is, we could say, shifted vertically up or down. And this ones are a little bit more friendly. When k, when it's plus k, we're like, oh yeah, moves, the parabola moves up, k units. Says units. And then when it's x squared minus k, this thing moves down k units. So far, so good? Yeah? Okay. Sorry, this is a brand new way that I'm teaching this. Usually it's a lot different. So if it's all is good, great. So here's a great example, because we're kind of going to look at the translations, and we're going to kind of make up our own quadratic in this new form here. It says the following transformations were applied to the parabola with the with the equation y equals x squared. Again, it's always based on this parent function. Determine the values of h and k and write the equation in this form here. So they kind of took that that h part of this and this k part of it and kind of mushed them together and made a brand new form of quadratics. So if this quadratic right here, the y equals x squared, if that parabola moved to the left, 7 units, what would that equation look like? Well, it did not move up or down, right? So that k value is going to be 0. But that h value, because it moved left, maybe I can write that over here. The h value we're going to sub in is going to be -7 because it was 7 left. And the k value, it didn't really go up or down, so we assume that that k value equals 0. Sorry, that says equals 0. So our quadratic is going to be y equals x minus, and you might write it like that, plus 0, I suppose, because it didn't move up or down. But we're not quite done with this because, again, this is not quite simplified here with this double negative. So really what we have here is y equals x plus 7 squared. And we don't need the plus 0 there. It's kind of redundant. So this should be our final answer here. I mean, you might get so good at this, you don't even write this first part, but I just want to show you what this thing looks like. Okay, how about the parabola moves 3 units up? Well, if it's moving 3 units up or down, we know that's the k value, and the k is going to be +3 because it moved up 3. So we assume that the h value here is 0 because it did not move left or right. So you might have something like this: y equals x minus 0 squared plus 3, maybe. Or maybe you're so good at this, you just went right ahead and said, okay, well, x minus 0 is really just still x. And so it's just going to be x squared and then plus 3. And this would be our final answer. Or maybe, again, maybe just jump to that answer right away because you're really comfortable and good at it. Now, we're going to kind of combine this. We're going to say, all right, this is more where we're headed with translations and transformations. How about this one? The parabola moves 2 units right. Well, okay. So we'll say h is 2, and then 5 units down. That means k is -5 because it went down. So our quadratic is going to look like this: y equals x minus 2, close bracket, squared minus 5. That's a great one. That's maybe where we're headed. Any questions about that? Okay, great. Okay, now example 2. They want us to do quite literally the opposite here. They say, all right, we give you the equations, you tell us in words what the translations were. So again, this is all going back to the parent function. I know I sound like a broken record, but it's really important that I stress that because when we're doing translations, and even when you do them later on, it always goes to the parent. Okay, so what happened here? X squared plus 6. It looks like this is the only thing that's a little bit different than the parent function. For the plus 6, we know, because it's not in brackets, must be the k value. And the k value is a vertical shift, either up or down. Because it's +6, we know it's up. So we'll say, and we have to use this really nerdy terminology here. We'll say something like vertical shift, or you might say vertical translation, up 6 units. Cool? All right. Next one. Now again, it's in the brackets. I want you to be extremely careful here. We got y equals x minus 2 squared. Now, we know that's the h value, and that h is a left or right movement. And it looks like it's x minus 2, right? It's laughing at us right now. It's trying to trick us a little bit. What do we know about when it says x minus 2? Is this a shift to the left because it's x minus 2, or is it to the right? Catalina, it's to the right, absolutely. So we'll say horizontal shift write 2 units. Okay, we got to be really cautious of those. And okay, have a look at this one. We got more than one translation in here. We have x plus 1, right? So this is going to be one of them. And then we have this minus 4 at the end here. So very much the opposite of the previous two. We have x plus 1 squared. So we know that is a horizontal shift to the left, 1 unit. Horizontal shift left, 1 unit. And then, so we got that one, right? That was the h value. Now, some of you might even write, okay, well, the h value there must be -1. And then the k value here is -4. Some of you might find that strategy appealing. And here we have a vertical shift down 4 units. Okay. Folks, any questions about those two? All good? This is great. This is great. Okay. Sketch now. Sketch now these things. Okay. Now, folks, there's a million ways to sketch quadratics. And again, the most powerful way to sketch any function of x, like linear function, quadratic function, and beyond, would be to build a table of values. And it truly is the most powerful way. But because quadratics are a little bit special here because they're symmetrical, they have a step pattern, and there's a whole bunch of really cool things that we know about them. There's many different ways to sketch. The textbook might like the way of to first sketch y equals x squared, and then take every single one of those coordinates and translate them based on the translations that they tell us, which is, again, that's a wonderful way to do it. But I think what I'm more headed towards is to graph these things using the vertex and the step pattern. That's more where we're headed. But I think, you know what, I think just for these two, I'm going to show you what the textbook is going to like to do a little bit more than what I'm about to do maybe later on. Okay? So here we have y equals x squared plus 3. And the parent function, I'm going to do the parent function in red. I'm going to do this, y equals x squared. I'm going to do this one on both of the graphs. So y equals x squared, it goes 0, 0 over 1, that's the vertex, right? And the way I graph this thing is by using the step pattern. You know, it's 1, 3, 5, 7, and 9. So over 1, up 1. Over 1, up 3. 1, 2, 3. Over 1, up 5. 1, 2, 3, 4, 5. Boom. Again, over 1, up 1. Over 1, up 3. 1, 2, 3. Over 1, up 5. 1, 2, 3, 4, 5. And this red parabola right here is, in fact, the graph of y equals x squared. Just the parent. Now, what we're going to graph is this thing right here, y equals x squared plus 3. Now, we know that plus 3 as a vertical shift up 3 units. Yes? So what we're able to do is we're going to take each coordinate from the original parent function and move them up 3 units. So vertex is going to go up 1, 2, 3. Boom. Coordinate to the right here is going to go up 1, 2, 3. Coordinate over here is going to go up 1, 2, 3. Okay, this one is going to go up 1, 2, 3. This guy here, 1, 2, 3. Now, I would do these two coordinates up there. I think they might be off the graph a little bit. 1, 2, 3, sure. 1, 2, 3. All right, fine. And then we end up with this curve like that. Now, that's what the textbook really likes to do. And some of us might be able to just look at this thing and know. Maybe you're at that point yet. You might just know that the vertex here is going to be at 0, 3. You might know that based on the investigation we had at the very beginning here. Not sure, but if you're understanding that the vertex is going to be 0, 3, what you could do is start at the vertex of 0, positive 3, and then use your step pattern to continue graphing the rest of the points. Because have a look, over 1 up 1, over 1 up 3, over 1 up 5. It's the same thing. Now, whatever strategy you like for example, this one right here, I think the vertex, we know this is a horizontal shift or horizontal translation 2 units left. So the vertex, because we're going 2 units to the left, it's going to be negative 2, 0 for the vertex. So we can just go ahead and graph that, right? Negative 2, 0, lovely. And then what we're able to do is just use the step pattern here. So the A value, I know it's not present. It's not actually like there, meaning it's 1. So we'll go over 1 up 1, over 1 up 3, 1, 2, 3, over 1 up 5, 1, 2, 3, 4, 5, and there we have it. That's one side of the quadratic. Next side, over 1 up 1, over 1 up 3, over 1 up 1, 2, 3, 4, 5, and there we have it. We don't actually need the original y equals x squared quadratic, but sometimes it does help. Do you see how it can help? Like, we could have graphed it here in the center and moved everything over 2 units to the left, and that would have been just as good. But the reason why I want to prepare you for the vertex and step pattern is because when we're doing all transformations, meaning when we start throwing in the A value into this mix, which is coming up soon, but maybe not in this lesson, it's going to be a lot more efficient to graph using the vertex and the step pattern. So for example, have a look here. Y equals x minus 1 squared plus 5. So really, what's our brand new, does anyone have any idea maybe? What's our brand new vertex? What is it? Yeah. Positive 1 because we went 1 unit to the right. I think H value was 1. And then the K value, well, the K, is it broken again? Oh, it is broken again. Okay, we're good. All right, don't give up on me yet, active board. Not even a May yet. K equals 5. So the vertex becomes 1, 5. Yes, absolutely. Now, I know it's not present in this quadratic, but what's our A value? Our A value is 1. So therefore, the step pattern is 1, 3, 5, ... and so on. Let me get the door. Oh, yeah, okay. Yeah. All right. Here we are. Our new vertex we said was, I'm going to do this one in blue. 1, 1, 2, 3, 4, 5. There's our new vertex in blue. We got it. Now we're going to graph the rest of the coordinates using our lovely step pattern. Over 1, up 1, over 1, up 3, 1, 2, 3. And then I guess we can't really do any more there, which is fine. So we'll go to the other side. Over 1, up 1, over 1, up 3. And what we can do is connect all of the lines here. And there's our quadratic. Now, before I let you off to the races, do you notice anything about this new form of quadratic and the vertex? The H and the K tell you what the vertex is. That's lovely. In fact, this form of a quadratic, which is really y equals, and I know we haven't seen it just yet, ax minus h squared plus k. This form right here is the brand new form that we're looking at in quadratics. And what we call it, actually, what do you think it's called? If we can get one specific coordinate out of this really easily, what would you call this form? No, we already have a form for standard. Well, we actually just call this thing vertex form. And such that the vertex is just h comma k. So when you look at this form, you're like, oh yeah, I know where the vertex is. Give me that thing. And we love this form. It's so good. It's amazing. And when it comes to translations, when it comes to finding maximums, minimums, things like that, if you can get a quadratic in this form, oh, you win. You win so big. And it's so good. Okay, getting too excited. So there's some homework here, just 1 to 5. Probably be able to finish it in class. We have a ton of time here. If you need graph paper, please let me know. I think I got some here. I got a hole punch up here. I got some of the sticky notes if that's what you're interested in. But I'm going to start inputting your
stuff and send you an email.